Assalamu alaikum. Now let's get to sample problem 5a page 112 in your book. The question says the AM radio band extends from 5.4 times 10 to the power 5 Hertz to 1.7 times 10 to the power 6 Hertz. So the givens here are two parts. First, F1 is given, first frequency 5.4 times 10 to the power 5 Hertz, and it says what are the longest and the shortest wavelength in this frequency range. So it says find two lambdas, one for the large frequency, one for the small frequency. So the givens are frequencies and speed of light, which is constant. What's asked is lambda here. So we will start from part A to find lambda 1 for F1. So first wavelength for first frequency. If you get to here we have the rule C is equal to F1 times lambda 1. We can see that speed of light is given, frequency is given, wavelength is asked. So in order to find wavelength, we have to change places. Here is done. Lambda 1 is equal to C over F1. It means speed of light over frequency. As we talked about in the notes before, we said if wavelength is asked, we have to change the place of the rule. So we will replace the numbers now. We have the speed of light here, we will put in here. Let's see, we have the frequency here, we will put in here instead of F1, and by dividing those numbers to find lambda 1 is equal to 3 times 10 to the power 8 over 5.4 times 10 to the power 5. We will get to the result of 560 meters. So this is the result of this division. You may find it like that in the calculator, or like this 5.6 times 10 to the power 2 meters. Whichever you find, it's correct. So which one you use, it's up to you, as you like. The second part of this question, it says F2 is equal to 1.7 times 10 to the power 6. Here F2 is given 1.7 times 10 to the power 6 hertz. Lambda 2 is asked, and C is given as constant 3 times 10 to the power 8 meter per second. We said you have to memorize the speed of light because it will not be given in the question. As you can see in sample problem 5a, the speed of light is not given in the question. So we will write the rule again. C is equal to F2 times lambda 2, the original rule, but we want to find lambda here. F and C is known, that's why we are going to change the rule. So it will be lambda 2 is equal to C over F2. Wavelength equal to speed of light over frequency, second frequency. So by replacing those numbers in the rule, by replacing instead of C 3 times 10 to the power 8 and instead of F2 1.7 times 10 to the power 6, by dividing those numbers we will get to the result of 180 meter, or as it's written in your book, 1.8 times 10 to the power 2 meters. Those are the result of the example of sample problem 5a. Now let's get to the practice 5a. This is your homework. Okay. The practice says a gamma ray bursts an object in the universe. Are objects in the universe that emits pulses of gamma rays with the high energies. The frequencies of most energetic bursts has been measured at around 3 times 10 to the power 21 hertz. So here f is given 3 times 10 to the power 21 hertz frequency. What is the wavelength of gamma rays? It says find lambda. So again, as you can see, speed of light is not given, so you have to memorize it. Second question, what is the wavelength range for FM radio band? Here again, wavelength lambda is asked, but we have two frequencies here. One of them is 88 MHz, one of them is 108 MHz. What are those M's means? Means mega. So you have to convert the power of mega to hertz. Be careful. Here we have 88 megahertz. You have to convert it to hertz. How can you change mega to hertz? The power of mega is 10 to the power 6. Here we have 108 megahertz. Again, you have to change 108 megahertz into 108 hertz. So 108 times 10 to the power 6 it will be. In the third question, it says a shortwave radio is broadcast between 3.5 and 29.7 megahertz. We have two frequencies here again. It says to what range of wavelength does this correspond? Again, you will find wavelength here. As we know, C is constant. Why do you suppose this part of spectrum is called short wavelength? Right? This part is not important, only the first part you can answer. So you will find wavelength here for two frequencies. So you will find two wavelengths here for 3.5 and 29.7. Each has its own wavelength lambda. Question 4. What is the frequency of electromagnetic wave? Here be careful, it says what is the frequency. In question 4 it says what is the frequency. So you have to find F here, because in the continue of the question says electromagnetic wave if it has a wavelength of 1 kilometer. So wavelength is given here. In here wavelength is given 1 kilometer, so you have to be careful. You have to convert this into meter again. What's the power of kilo? It's 10 to the power 3. Question 5. The portion of visible spectrum that appears brightest to human eyes is around 560 nanometer in wavelength, which corresponds to yellow-green. What is the frequency of the light? Again, in the question 5 it says find frequency. Question 6. But according to question 5 you have to be careful about 560. It says nanometer. Be careful. We have to again convert nanometer into meter. What is the power of nano? It's 10 to the power minus 9. So how can you convert 560 nanometer into meter? You have to first convert and then find your result. Question 6. What is the frequency of highly energetic ultraviolet radiation that has a wavelength of 125 nanometer? Again, we have nanometer here. We have to convert it to meter and then find frequency. Here again lambda is given. I have to find frequency. Thank you for listening.